In today's class, we are going to discuss about problems on sequence and series by using telescopic method to find out its sum. The problem is on your screen. Very simple looking problem. Fn equals to greatest integer function root n plus half. Then find sigma n starts from 1 to infinity 2 to the power fn plus 2 to the power minus fn divided by 2 to the power n. The problem is this. Okay. So I will suggest everyone to pause the video right here and at least give a try to this sum. At least for 5 minutes. If you cannot do the problem, or even if you can do the problem, come back to the video and see the solution. So let's start this sum. We have been given that Fn is greatest integer function root n plus half, where n is a natural number. Now a very interesting thing is happening here. Say if n is 1, then your f1 is taking the value greatest integer function 1 plus half, that is 1.5, which gives us 1. Now if n takes 2, then your f of 2 becomes greatest integer function root 2 plus half. Root 2 is 1.414 approximately plus 0.5. That gives us greatest integer function 1.914, which is again equals to 1. So what we have observed? We have observed that for one value of n, we are getting more than one value of fn. That is, it is a many one function, right? So what I want to do here is, let us assume that your fn is some integer. Let us say the integer be m. M is an integer, okay? Or more precisely, you can say that m is a natural number, as n is a natural number. Now, as greatest integer function root n plus half is m implies, this part will lie between m and m plus 1. So we can write in this way. Let me square both sides. So if I break it, what we are going to have, m square minus m plus 1 over 4. M square plus m plus 1 over 4. Okay. Now, m square minus m plus 1 over 4. This can also be written as, we all know that 1 over 4 is greater than 0, less than 1. So if I add m square minus m on both sides, we are actually having, it means that m square minus m plus 1 over 4, this belongs to m square minus m square minus m plus 1. Am I correct or not? Okay, similarly, we can say that m square plus m plus 1 over 4, this belongs to m square plus m square plus m plus 1, right? Now, we already got that your n is lying between these two values, okay? The range of n we got. and your n is always greater than equals to m square minus m plus 1 over 4 and always less than m square plus m plus 1 over 4. So now from this range, we can say that your n is always greater than or equals to m square minus m plus 1, and it is always less than or equals to m square plus m. This is always true. Please check this one. This is always true because as your m square minus m plus 1 over 4 is lying between this, so whatever may be the value of m, if I say that your n is greater than or equals to m square minus m plus 1, it satisfies all the values of m for n. Are you getting the point? And that exactly what I have written, that whatever may be the value of m, your n is always lying between m square minus m plus 1 and m square plus m. Is it clear to everyone? You can check it also. If I take that your m is 1, as we got here, when n is 1, your n is taking the value either this one, or n is taking the value 2. So for m is 1, your n can take two values, 1 and 2. And that exactly you are getting from here also. Please check it. If n is 1, in the left hand side you are getting 1 minus 1 plus 1. 1 plus 1. So your n is basically lying between 1 and 2. That implies your n will be 1 and your n will be 2. Getting the point? So your n is lying between this range. This is the first trick that we have learned. That whenever there is some value which is inside the greatest integer function, you can take it out by using this method. When you find that a function is a many one function, when you need that your n has to be expressed in terms of m, in this case, we will simply extract n and we will write that n in terms of m, as I have done it here. Okay, so now we got that n is from m square minus m plus 1 and m square plus m. Now let us come to the question. We have been given sigma n starts from 1 till infinity. Okay, if n starts from 1 to infinity, then your m actually also starts from 1 till infinity. And I am introducing a second sigma. This is for your n. Your n will start from, as we got the range, m square minus m plus 1 to m square plus m. And the function becomes 2 to the power m, because fn is m, plus 2 to the power minus m divided by 2 to the power n. So we can write this thing like, I can take this 2 to the power m plus 2 to the power minus m outside the inner sigma. And for this it is n equals to m square minus m plus 1 till m square plus m, 1 over 2 to the power n. Now 1 over 2 to the power n, it is basically a GP series whose first term is, I'm writing it here, whose first term is 1 over 2 to the power m square minus m plus 1, and the common ratio is half. And how many number of terms are there? Number of terms is equals to m square plus m, the upper limit minus the lower limit, plus 1. So we are actually having So it gives us m square goes off, 1 goes off, so it is 2m. So how many number of terms are there? There are 2m number of terms. So if I apply the formula for finding out the sum of a GP series, so the inner sigma, I'm writing it here. So the thing becomes something like this. M is from 1 to infinity, 2 to the power m plus 2 to the power minus m. And I'm applying the GP summation formula. It is A into 1 minus r to the power n. R is half. And this is 2m divided by 1 minus half. A into 1 minus r to the power n divided by 1 minus r. So we are actually having 2 to the power m plus 2 to the power minus m into 1 over 2 to the power m square minus m plus 1 into 2 into 1 minus 2 to the power 2m. Okay? So that gives us 2 to the power 2m plus 1 divided by 2 to the power m into 1 over 2 to the power m square minus m into 2 to the power 2m minus 1 divided by 2 to the power 2m. Okay? So now if I add, we are going to have m is 1 till infinity, 2 to the power 2m plus 1 divided by 2 to the power m square into 2 to the power 2m minus 1 divided by 2 to the power 2m. Okay? So now we are getting actually m is from 1 to infinity, 2 to the power 2m plus 1 into 2 to the power 2m minus 1 divided by 2 to the power m square plus 2m. Am I correct? So let me just copy this one. So this can be written like m is from 1 to infinity. This is 2 to the power 4m minus 1 divided by 2 to the power m square plus 2m. Correct? If you want to separate this, you can do that. 1 till infinity 4m divided by 2 to the power m square plus 2m minus 1 over 2 to the power m square plus 2m. Correct? Now obviously here it is clearly indicating that it requires now the telescopic method to find out its sum. So we can write this thing like m is from 1 till infinity. This is 1 over 2 to the power m square minus 2m minus 1 over 2 to the power m square plus 2m, right? Now if I take Gm be 1 over 2 to the power m square minus 2m. So in this case, what is your G of m plus 2? 2 to the power m plus 2 whole square minus 2 times m plus 2. So that gives us 1 by 2 to the power m square plus 4m plus 4 minus 2m minus 4. So that gives us 1 over 2 to the power m square plus 2m, right? And that exactly what is this. So this is basically our Gm and this is our Gm plus 2. Okay? So the sigma becomes what? M is from 1 till infinity. The thing becomes actually Gm minus G of m plus 2. But here we cannot apply telescopic method. To use telescopic method, the difference should be 1. I mean, if it is Gm, there should be a Gm plus 1 or m minus 1. Okay? And m plus 2 is there, so I need G of m plus 1 or m plus 3. means the gap should be of 1. That's exactly what I want to tell you. So let me just do one thing. Limit m is from 1 till infinity. I'm simply manipulating this by subtracting gm plus 1 and then adding gm plus 1. So it will get nullified and the thing will become like this. Okay. Now if I separate these two sigmas, so it's gm minus gm plus 1. This is 1. And another one is sigma gm plus 1 minus g of m plus 2. Correct? Now see one thing. Here actually, what is your gm? I've already written here. What is your gm? Gm is basically this one. Okay? So now, this one is lower one and this one is higher one. So in place of m, I will simply write g1 minus g of m plus 1. So the higher one, in place of m, I will write infinity. I mean, it will tend towards infinity. Now, as m tends towards infinity, g of m plus 1 will become what? Its limit m tends to infinity. G of m plus 1 will give us actually 1 over 2 to the power m plus 1 whole square minus 2m. Okay, so that will give us 1 over 2 to the power m square plus 2m plus 1 minus 2m minus 2. So that actually comes like 1 over 2 to the power m square minus 1, as m is tending towards infinity. So 2 to the power m square minus 1 is also tending towards infinity, and therefore it is tending towards 0. So this one will become 0. Okay, now again for the second sigma, this one is the lowest one and this one is the highest one. So if I put m is 1, we are going to have g2 over here. And this will again tend towards infinity in the similar way, because your gm plus 2 is this one. As m is tending towards infinity, 1 by 2 to the power m square plus 2n is also tending towards 0. Therefore, your answer will be g1 plus g2. And gm is this, so from here we can easily see that your g1 is coming to 1 over 2 to the power 1 minus 2, that gives us 2. And g2 is coming to 1 over 2 to the power 4 minus 4, that is 1 to the power 1 divided by 2 to the power 0, that gives us 1. Therefore, your answer will be 2 plus 1, which is equals to 3. Is it clear to all? So this sum is a fantastic sum, because this sum actually comprises of 2-3 different conceptions. And one who have understood this sum by heart, he will simply remember the tricks that I have applied here, so that in coming days, if critical question comes on telescopic sequence, you can handle that. Okay? So let us take another problem of that kind. So this question. So in this question, we have been given this thing. Now we have to find out the sum. Easily we can understand that this kind of problems can only be handled by telescopic method. Otherwise you cannot find out its sum, because this is not a normal sequence. Okay, so what to do this? Here we can see that there are some terms which are common. We can find that root over of 2r minus 1, that can be taken common. At the same time, root over of 2r plus 3, that can be taken common. So we are left with root over of 2r minus 1, 2r plus 3. I'm sorry, 2r plus 5. And for the second one, root over of 2r plus 3 and 2r plus 1. Okay? Now what? Let me rationalize this. So if I rationalize, we are going to have two r plus 5 minus root over 2r plus 3, 2r plus 1, and in the denominator we are having 2r minus 1 and 2r plus 3, that is there, and this thing will become a square minus b square. So 2r plus 5 minus 2r plus 3 into 2r plus 1. Okay? So let me just take 8 outside the sigma. And in the numerator, we are having the same thing. I'm not writing it anymore. Let me just simplify the denominator. So in the denominator, if we just open the brackets, we are getting 4r square minus 2r plus 10r minus 5. And here it will be minus 4r square minus 6r minus 2r minus 3. This goes off. And here we are having 6, 7, 8, 9, 10. Okay, this also goes off. So we are left with minus 8. Okay. So now this 8 and this 8 will go off. So we are left with r is from 1 till infinity. The numerator thing is there. 2r plus 5 minus root over of 2r plus 3, 2r plus 1 whole divided by 2r minus 1 into 2r plus 3. And now if we separate, we are going to have 1 till infinity. When this divided by this, when this one is divided by this one, we are left with under root. Let me change the color of the pen. So this one will be root over of 2r plus 5 divided by 2r plus 3. And for the second one, it will be root over of 2r plus 3 will go off. So it is 2r plus 1 divided by 2r minus 1. Okay. Now we can easily see this thing. If I denote this thing by my GR, that is, your GR is root over of 2r plus 5 by 2r plus 3. So what will be your G of r minus 2? It will be 2 times r minus 2 plus 5 divided by 2 times r minus 2 plus 3. So that gives us under root 2r plus 1 divided by 2r minus 1. So this is basically your G of r minus 2, right? Now to apply the telescopic method, all we need is to form a sequence where the difference is 1. That is what I want to say is, if I write this one in this way, sigma r is from 1 to 8. This is basically G of r minus 2 minus of GR. So all I have to do is, I will write in this way. g of r minus 2 minus of g r minus 1 plus g of r minus 1 minus g of r, correct? Now, for this one, the lowest is this, the higher is this. So in the lowest, I am going to put r equals to 1. So you are going to have g of minus 1. And for this one, in place of r, oh, it's not 8 actually. This is actually infinity, right? This is infinity. That's not 8. Okay, so in place of r, because this is higher, so your r will tend towards infinity. Now we can easily see that your g of r minus 1 is basically under root 2 times r minus 1 plus 5 divided by 2 times r minus 1 plus 3. So that gives us root over of 2r plus 3 divided by 2r plus 1. And as your r is tending towards infinity, this one will give us 1. So your g of r minus 1 will give us 1. This is also 1 minus, okay, just one second. This one, when it is separated with the sigma, the lowest one will get r equals to 1. This is the lowest one, so it will be z of 0 minus, this is the bigger one, so this r will tend towards infinity. Now when r is tending towards infinity, from this one we can easily see that when r is tending towards infinity, the function is tending towards 1. So this is again 1. So we are actually having g0 plus g of minus 1 minus 2. Am I correct? So what is g of 0? G of 0 will give us root over of 5 over 3, and g of minus 1 will give us, in place of r, I am putting minus 1. So we are having 3 over 1, right? Minus 2. So your answer will be what? Root 3 plus root over of 5 over 3 minus 2. And that's your answer. Is it clear to everyone? So that's all for today's class. See you tomorrow. Till then, take a very good care of yourself. Thank you so much.